Hi, it's Paul Beckwith, continuing my AGU mishmash. Just want to re-emphasize a very important talk on the Arctic. Before the 1990s, it was warming 0.6 degrees Celsius per decade. After the 1990s, that jumped to 1.67 degrees Celsius per decade. Almost a 3 times increase on a decadal basis. If you look on a yearly basis, it's gone up even more in the last number of years. We can associate the Pacific Warm Blob with the warming of the Arctic, also with the Atlantic Cold Blob. Arctic warming is behind a lot of these things that are happening. 1965 to 89, we consider the Arctic to be cold Arctic. From 1990 onward, a warm Arctic, and then you get this tropical northern hemisphere TNH pattern, which was described, and you get these different marine extreme events occurring. So this was a key thing, and I talked a little bit about that in the previous video. Now, I talked about Dan Rather's keynote. There was another keynote. This was December 14th on Thursday. It was called How a Geoscientist Can Change the World. It was by Dr. Von Torrential. And so it was Thursday, 12:30 to 1:30, December 14th. He's the Senior Board Director for Sustainability Programs at the U.S. National Academy of Sciences. He got this role in July of this year. Before this, he served as the 5th Science and Technology Advisor to the U.S. Secretary of State. So he advised the Secretary of State and other State Department officials on international environment, science, tech, and health matters affecting foreign policy of the U.S. Okay, and it goes on. I'll put his bio. I'll do an image capture of this and provide you with his bio. So he was basically, how can a geoscientist change the world? He talked about Dave Keeling and his work in the late 50s, the Keeling curve, measuring a CO2 record. Many people at the time sort of laughed at him. They said that's not science, that's just a measurement, simple measurement thing. That continuous record since, 58 has been crucial for understanding how CO2 has risen in the atmosphere. The ozone problem. Paul Crutzen, Molina, and Rowland, they got the 1995 Nobel Prize for their ozone work in the 80s, which led to very quickly to the 1987 Montreal Protocol, which is arguably the best example of international cooperation to deal with an environmental event that's getting out of control. Okay, we need to replicate this multifold to deal with climate change. June 24th, 1988, New York Times headline was, "Global warming has begun, expert tells Senate." Okay, many of you probably know that this was James Hansen, who testified to the Senate about climate change / global warming. Bush, 2001, the National Academy of Sciences had a climate report. Alan Roebuck was involved, and it talked about how there was unequivocal effects of warming from greenhouse gases in the atmosphere. So this stuff goes back. So Torrential he talked about the Sustainable Development Goals and how important it is to educate the youth. So in 2016, John Kerry taught high school students about the oceans. He went into a high school and he stood in front of a periodic table, and there's a famous picture of him, and he taught students all about the ocean. So he boned up with oceanographic experts and stuff so that he wouldn't be stumped by these high school students. One thing he did say is, they said, "Don't you have more important things to do?" And he says, if we don't get this right, then nothing else is important. Okay, so, it's very important to, educate our youth on the importance of science and getting them interested in science. I mean, science is interesting. If it's not interesting, then it's not being taught correctly. 14 countries have science and tech advisors to foreign ministers. I mean, we need this more and more. We definitely need science advisors. We need to embrace science and use science more and more in politics, and reverse the trend that we have with the present U.S. government. Substance is the bedrock of friendship in terms of international relationships. You have to have substance behind what you say. It can't just be opinions and propaganda. There's 17 sustainable development goals. You can just Google and have a look at them. There's a lot of overlap between the AGU and these goals. They involve a lot of science and engineering and social science and leading to policy. One of the interesting things is that next year the AGU conference is in Washington, D.C. So the 2018 meeting is on the turf of all of the politicians. So, if there's 25,000 scientists there, if there's groups that can organize them, maybe Citizens Climate Lobby and other groups, if there's a huge effort, these scientists can completely infiltrate all the corridors of power, in the few days before or after the conference with lobbying. If they can be organized and hook up with, with lobbying firms and lobbying people, that could make a big impact to the government, perhaps. This is one of the things that it's a golden opportunity, according to Torrential, that this could be done. He says everything's underpinned by science, its goals, its discoveries. Right? Science is behind all of this. So, he's also saying, in terms of advice, career advice and stuff, saying, it's very easy to get tactical. It's harder to stay strategic. Strategic is having longer term goals, and tactics is what you do day to day to get at those goals. Any chess player, knows the difference, or if you play board games and things, these two differences are crucial. Tactics came very naturally to me in my chess. Strategy I had to work at a lot harder, but when I did get strategy down pat, my rating jumped up in chess. Skills are fungible. Okay, this is a good word, fungible. Money's fungible, right? You can raise it from one purpose, but it can be used for any purpose. So, it's transferable, basically completely transferable. So skills are fungible. They can be transferred to many different things. And he gave his sort of rah-rah, life's a journey, adapt, mitigate, expand, travel, things like that. So, anyway, it was a very, very good talk, very interesting talk. And there were some insights on how to get the ear of politicians, which is vitally needed by scientists, for scientists to step out of their comfort zone and do some of these things. There was a talk on key Arctic indicators, and I won't go into that because I'll probably give a separate video on discussing the details of the Arctic report card, which was released at the conference. One of the things, there was some methane talks I went to, but they were on the U.S. methane inventory, so these are somebody from the U.S. EPA was talking, somebody from energy company was talking about methane policies. The buzzword is LDAR, LDAR, leak detection and repair. In wells, the water builds up and has to be released. So when it's released, there's methane that's released to the atmosphere. This is periodic, and it's hard to overcome this. So they need to, think about how to get that methane out. Methane leak rates are, of course, very, very high. In 3 U.S. basins were looked at. Aircrafts overflew. They used a Picaro cavity ring-down laser to detect methane to high concentration. There were huge differences in leak rates. Like the Marcellus Shale in Pennsylvania was quite low. The Uintah Basin, the DJ Basin, like leak rate 6 to 12%. So that's one of the things with leak rates. And I found out this at a methane conference in Ottawa. If you get the top, there's super emitters in methane. Some places just emit huge amounts, and other places on average are much lower. So if you get rid of, if you tackle those super emitters and shut those down, you can make a huge dent with the minimal amount of effort. So hopefully that's done now that we have better metrics to measure the stuff. There wasn't a lot of stuff on methane. Maybe not many Russians there. A lot of work is done there. I don't know. There were permafrost sessions, but not much on methane from what I could see. I think that would be a weak point of the conference, if you like. I went to extreme precipitation talks. Okay, Trenber's student. I thought Trenberg was giving the talk, but I think it was his student talking about daily precipitation extremes. As temperatures increasing, you get a precipitation response where it peaks at a certain temperature, and the whole thing can shift with climate change. Of course, 7% more water vapor in the atmosphere per degree Celsius, but the amount of precipitation is about 3 to 5% per degree Celsius of warming. It's not that full 7%. The extreme events, there'll be 7% more water vapor and 7% more of the extreme, deluge events, but the precipitation overall is up 3 to 5% per degree of warming. There was some discussion of extreme precipitation in the tropics and how to determine if it's changing. Matthew Igel was looking at global precipitation and how that was changing and how it depended. He looked at things like column humidity and data from AIR's atmospheric infrared satellite systems to look at relative humidity and to find out how the precipitation was changing and how the frequency of precipitation was changing, and he tried to model these things and fit some curves. It got pretty technical, so I'm not going to get too much into that. Exeter University, Matt Hawcraft talked about precipitation extremes in Europe. Again, precipitation increases 2 to 3 degrees per Celsius or per Kelvin, and extremes increase 7%, same as the water vapor, because they're based on energetic processes. So he looked at the statistics of different storm tracks and flooding events and persistent events and things, and looked at extratropical cyclones, and he found that the most extreme storms, the 99th percentile, greater than 99th percentile storms will triple in the near future overall, and they'll go up 4 to 5 times the most damaging storms in Europe, for example, by 2100, but I think it's earlier than that. He talked about the nature of the storms and also how they'd happen on a seasonal basis, like June, July, August, up 500%. Really extreme storms and precipitation. So summer storms are the most extreme and will have the most rise under climate change. Then I asked the question, have you correlated your spatial results of extreme weather event, extreme precipitation events changing with food growing areas around the planet? To see how it would affect our food supply. So the answer was no, that would be interesting to do. Well, yeah, it will be interesting to do, right? We need more of this cross-disciplinary stuff. Another talk was on squall lines and things. There was also talks on, how do we get this information out to the people? I mean, like, we have an organizational problem. I guess I wrote down my own notes at this time of the conference. I said, look, scientists want change. They understand climate change. Engineers, they want to change, right, to build things better. Policymakers claim they want to change. Some governments do, but we have an organizational problem. We need a new organization or new connectors in different groups. We need to treat climate change seriously as an emergency, and then deal with all of this stuff. More Arctic amplification talks, ocean talks, things like that. I've run out of time. Thank you.